Hey everyone, welcome back. I am the Electrical Code Coach from electricalexamcoach.com. This is lesson 6.1 in our video series. Today we're going to be learning all about box fill. We're going to be in section 314.16, and we have two primary tables that we're going to be using. The first one that we're going to cover is 314.16a. Let's get to it. On the left-hand side is going to be our box size in inches. The next column over is going to be the type of box, and there are several different types of boxes. The first one is going to be the round octagonal box. A round box is truly circular, and the picture listed here is actually an octagonal box. I want to give a shout out to homedepot.com. It's where I snagged all these pictures. The next three lines you'll notice say square, and these boxes are true 4-square boxes. They're 4 by whatever the depth is. And if you look back over here to your dimensions where the box size in inches is listed, this box states that it's a 4 by whatever the depth is. There are 3 different depths. The next 3 lines you'll notice say square as well, but its dimensions are a little bit different. It says 4 11/16 by 4 11/16 by whatever the depth is. Down below there start your device boxes in all different shapes and sizes. Finally, we come to our masonry boxes. Listed below there, you're going to see different type of raised covers, which also give you a little bit more cubic inch volume inside of your box. The next column that we need to pay attention to is this middle one right here. Now, in the NEC, it actually says a minimum volume, which is kind of deceptive to the installer because it's actually your maximum volume that you're allowed to fill that box. And it's listed in cubic inches. That's all we're concerned with. We're not concerned with any metric designators inside of this table. We want to be dealing with cubic inches. And the reason it's cubic inches is because we have 3 different measurements. We have 4 by whatever the depth is. In this column, you're going to find the maximum that you're allowed to fill each box. Then when we come over here to the far right of the table, it's one of my favorite pieces. It's actually like a cheat sheet. If all of your wires are of the same size, you can use this part of the table and make it very simple on yourself. First thing you'll do is you'll come over and find your gauge of wire. Then you'll come over here and find your type of box, and then come over and tee off with how many wires can fit inside of that box. It's very simple. Now let's look at the second table that we're going to be dealing with for box fill. And it's right below there. It's 314.16b, and this one's very simple to understand. On the left-hand side is our conductor size, and on the far right-hand side is going to be our cubic inch volume. Every box can only handle so many wires and devices, and that's what we're going to learn in this lesson here today. Each box has so many cubic inches that you can fill, and each conductor and device takes up so many cubic inches of that box. Now, let's do some practice questions and get to it. What size round octagonal box would you select for 9 number 12 conductors? For this one, we're going to be using table 314.16a. We're going to start here and we're going to find our gauge of wire. Then we're going to come down and we're going to find a box, making sure to cross over and double check that we don't crest over into a different style box. We want to stay in the round octagonal. We find our conductors, we find the one that fits it, we slide over and double check ourselves, and we're going to select A. Great job! What size round octagonal box would you select for 7 14-gauge conductors? We're going to head to table 314.16a. We're going to start here on the right-hand side and we're going to find our gauge wire. Then we're going to come down and find a box that fits it and be sure when we cross over that we stay in the right category of box, and we're going to select C. What size 4-square box would you select for 8 number 8 conductors? We head to 314.16a. We're going to start here on the right-hand side and we're going to find our size wire. Then we come down and make sure that we're in the right type of box. We cross over and we're going to find that it's A. How many number 10 conductors can you fit inside of a 4 11/16 by 1.5 inch square box? It's the same process, just looking at it differently. We're going to go ahead and come to our table, 314.16a. We're going to find our gauge conductor. We're going to come down and find our box, make sure we cross back over, and we find that we can fit 11 inside of this box. How many number 8 conductors can you fit inside of a 4 by 2 1/8 by 1.5" device box? We head to 314.16a. We're going to find our gauge wire. Then we're going to come over and find our type of box and size, make sure we do everything correctly, and we're going to find that it holds 3. What is the maximum cubic inch volume for a 3 3/4 by 2 by 2 1/2 masonry box? For this one, we're going to head to 314.16a, and we're going to use that middle column, that volume column, and we want to find out how many we can do. We come down, we look very closely, and we find that it's 14 cubic inches. This is very important that we understand this process before we move on into more complex box fill calculations. What is the maximum cubic inch volume for a 4 11/16 by 1.5" square box? We're going to use the same process. We head to our table. We're going to go to that volume column, and we're going to come down and find our correct type of box, and we're going to find that it's 29.5 cubic inches available area to fill. How many more number 10 conductors can you fit inside of a 4 11/16 by 1.5" square box that already contains 6 number 10 conductors in it? Well, since both of these are of the same size, we can just do some simple math. First, we have to find out how many the box holds at all. And we go in and we find that it holds 11. Then we have to do some simple math. We already have 6 conductors, so we take our original 11 minus 6, and it lets us know that we can put 5 more inside of that box, and we select A. How many more number 12 conductors can you fit inside of a 4 by 2 1/8 by 2 1/8 device box that already contains 5 number 12 conductors? For this one, we're going to head back to our table 314.16a. First, let's find out how many wires it can hold originally. It can hold 6. We already have 5, so we take 6 minus 5 equals 1, and we can put 1 more conductor inside of this box. What is the cubic inch volume for a number 6 conductor? For this one, we're going to head to 314.16b. We're going to start here on the left-hand side of the table and find our size conductor. Then we're going to come over and we're going to cross over to our cubic inch volume, and we're going to select D. Great job. What is the cubic inch volume for a number 12 conductor? Head back to 314.16b, start on the left-hand side and find our size conductor, then cross over to the cubic inch volume, and it's stating that for every number 12 that's in that box, according to the count, which we're getting ready to learn, takes up 2.25 cubic inches of that box. Let's get to it. What is the total cubic inch volume you would calculate for 4 12-gauge conductors and 3 14-gauge conductors? First thing we're going to do is head to our table. Now we have to do some simple math. Let's grab all of our 12-gauge conductors first. We have 4 of them. Multiply it by 2.25. That equals 9 cubic inches. Now let's snag our 14s. We take 3 multiplied by 2, and that gives us 6 cubic inches. But now we can't forget to add them back together. Total it all up, and these conductors are taking up 15 cubic inches of this box, and we're going to select C. What is the total cubic inch volume for 3 10-gauge conductors and 5 8-gauge conductors? We head straight to our table. We do some math here. We bear out the 10-gauge conductors. Then we bear out the 8-gauge conductors. We total those two back together, and we find that it's taking up 22.5 cubic inches, and we select B. What is the smallest device box you could use to fit 4 12-gauge conductors and 3 14-gauge conductors? For this one, we're going to be using tables A and B. Let's start over here in table B and get our total count. Then we'll go to table A and find which box fits it. We do the math on our 12-gauge conductors. We do the math on our 14-gauge conductors. These conductors are taking up 15 cubic inches. The code wants to know the smallest box that will fit it. So we come over here to our middle column, the volume column, and we slide down until we find a device box that just fits it. And we're going to find that it's a 3 by 2 by 3 1/2. What is the smallest round octagonal box you could use to fit 3 10-gauge conductors and 3 12-gauge conductors? For this one, we're going to be using both the tables again. Let's go ahead and bear all of our math out. And we find out that these conductors are taking up a total of 14.25. Now let's head over here to table A and go down the volume column until we find the right type of box, which is right up here at the top, the round octagonal boxes. Find the one that fits, and it's a 4 by inch and a half. Great job. Now let's learn about the rules for box fill. We're getting ready to cover a lot of ground, and this is something that you have to master. But don't feel like that you have to master it in one pass. Watch this part of the video over and over until you thoroughly understand it. We're going to learn how to count conductors now for our box fill calculations. We have to accommodate for each wire and then also for the different devices and fittings that we use out in the field. We're not going to be dealing with equipment grounding conductors at first. We're going to calculate those separately at the end of this slide. So now we're dealing with only neutrals and hots. Each conductor counts as one of whatever gauge it is. So each 12 counts as one, each 10 counts as one, whatever gauge wire it is. Each conductor that passes through the box counts as one. So even if it doesn't terminate or splice inside that box, if it's passing through that box, it counts as one each. Each internal clamp only counts as one total based off the largest conductor that's in the box. Let me show you what I mean. This is an internal clamp. The clamping mechanism is inside the box. Well, it's taking up some of my space, so we have to account for it somehow. What this code is stating is it doesn't matter if I have 1 or 5 of these clamps, we're only going to count it as one, and it's going to be grouped with whatever the largest conductor is in the box. Meaning if I have 12 and 10 gauge conductors inside that box, this internal clamp would count as one 10 gauge conductor. All of the fittings we're going to convert over to conductors, then the conductors we're going to convert over to the cubic inches, and you'll know more of what that means as we go through this lesson. This is an external clamp because the clamping mechanism is on the outside of the box, and we don't have to count those at all for box fill purposes. Next, each stud or hickey that is present in the box shall count as one total based off the largest conductor that's in the box. Now, these are really old words, probably from the 30s if I had to imagine, but they still use them on examinations today. And this is what we're talking about. Imagine that we're hanging a chandelier. This we would call the stud or the nipple. Or, this would be the nipple, this would be a nipple. But they're calling this the stud and this a hickey. And they still use this terminology on exams today, so you definitely need to understand. In this scenario here, in this picture, the stud would count as one of whatever gauge was in the box that was the largest, and the hickey would count as one of whatever gauge was in the box that is the largest. And we're going to do lots of practice, so don't worry about it. Now we need to account for device straps and yokes. What the code states is that for each device strap or yoke, it's going to be counted as 2 based off the largest conductor that's connected to the device. As we learned earlier in the program, this is a device yoke or what we call a device strap. So each one of those, and how I like to think about it, is each gang of a box. If you have a single gang box, 2 gang box, or 3 gang box, each gang is going to count as 2 based off the largest wire that is connected to the device. So if I had a box that had 12 gauge on one switch and 14 gauge on another switch, the first switch would count as 2 12s and the second switch would count as 2 14s. Now let's deal with equipment grounding conductors. Let's deal with the 2017 first. If you are on the 2017 code, this is how you deal with equipment grounding conductors that are in the box. It's only counted as one total based off the largest conductor in the box. Meaning it doesn't matter if you have 10 equipment grounding conductors, they all only count as one for your count total, and it's based off the largest conductor that's in the box. So if I have 10s and 12s, it's only going to count as one number 10. Now in the 2020 and in the 2023, it's a little bit different. Up to the first 4 conductors, it's going to count as 1. Then for every one that is past 4, you're going to increase it by a 1/4 inch volume. And we're going to do some practice questions with these. Just let that soak in, and when we get to the practice questions, we're going to expound on it more. If you're still on the 2017, when I come to this part of the lesson today, I want you to just fast forward through it. You don't need to learn it. It will just confuse you. 2017 will come first, and the questions will state what year I'm dealing with. Then when we get to the 2020 and the 2023, I'll let you know, and that way you can learn your respective lesson. Let's get to it. What is the total cubic inch volume you would calculate for a light box that contains 3 12-gauge conductors with 1 stud and 1 hickey present in the box? For this one, we're going to go to table 314.16b. We know that each 12 is 2.25 cubic inches. Now let's count our conductors. We know that we have the 3 number 12s originally, but now we have to deal with the studs and the hickeys. Our code states that for each stud and each hickey, they count as 1 each based off the largest conductor that's in the box. In this case, we only have number 12s, so they're going to be grouped with the 12s. So that lets us know that we have a total of 5 number 12s. That's what I meant by we're converting everything back to conductors, and then we can do our multiplication. We take those 5 number 12s, multiply it by the cubic inch volume for 12, and we end up with 11.25 cubic inches, and we would select C. What is the total cubic inch volume you would calculate for a light box that contains 3 number 12 gauge conductors, 3 14 gauge conductors, and 1 hickey present in the box? We'll head to our table. We know that each 12 is 2.25, so you always deal with the largest conductors first. And the reason is because your fittings are likely going to be grouped with the largest conductors. We know that we have the 3 number 12s, but now we got to deal with our fittings. In this case, we have 1 hickey. Each hickey counts as 1 based off the largest conductor that's in the box. And what we're going to do is group it with the 12s. We have the 3 original conductors, the 1 fitting. We have 4 number 12s. We bear that math out and end up with 9 cubic inches. Now let's deal with our leftover conductors. We have 3 14 gauges. We take and bear all that math out. Then we total it together and we end up with 15 cubic inches that all of this is taking up in this box. This is something that you'll have to take your time and master. One of my favorite sayings is, you don't wake up on that level. You don't wake up understanding this. You don't watch the video once and get it. If it were that simple, anybody can do it. I hope it's been very easy for you to understand up until this point, but for you to truly master it, you got to get after it. What is the total cubic inch volume you would calculate for a box that contains 8 number 12 gauge conductors and 2 single pole switches in a 2-gang box? We look at 314.16b. We know that each number 12 is 2.25. Let's go ahead and count our conductors. Each device yoke counts as 2 based off of whatever wire is terminating to the device. We know we have 8 original conductors, and we only have 1 size wire, so we know it's going to get grouped with the 12s. And each one of those devices counts as 2, so we end up with 4 more number 12s, which gives us 12 12-gauge conductors. Now we take and do our math, we end up with 27 cubic inches, and we select B. What is the total cubic inch volume you would calculate for a box that contains 8 12-gauge conductors terminating to 2 single pole switches, 6 14-gauge conductors terminating to 2 single pole switches in a 4-gang switch box? This looks like a tough question, but I know that you can do it. First, we're going to head to our table so we can get our values. We know what each 12 is, and we know that each device yoke counts as 2 based off the largest wire that's terminating to the device. Let's go ahead and deal with our 12s. We know that we have 8 conductors and 2 devices for those 12s, so each one of those devices counts as 2 more, giving us a total of 12 12-gauge conductors. We take and bear the math out, and we end up with 27 cubic inches. Now we just do the same for the leftover devices. We have our 6 original conductors, and we have 4 more based off of our count, because remember, it's based off the largest wire that terminates to that device. We take and bear that math out, total the 2 together, and end up with 47 cubic inches. Let's get to it. What is the total cubic inch volume you would calculate for a box that contains 3 internal clamps and 4 12-gauge conductors? We head to our table. We know what each 12 is. All internal clamps count as 1 total based off the largest conductor in the box. We only have one size wire in the box, so we're good to go. We take our 4 original conductors plus our 1 clamp count, and that equals 5. We bear our math out, and we select C. Now let's deal with equipment grounding conductors. In the 2017, all equipment grounding conductors just count as 1 based off the largest conductor in the box. 2020 and later, all equipment grounding conductors count as 1 based off the largest conductor in the box, up to 4 conductors. So 4 conductors and under count as 1 total. But when you have over 4, there's going to be a 1/4 inch volume increase that's going to be added for each additional equipment grounding conductor after 4. I'm going to teach you how to do it one step at a time. What is the total cubic inch volume you would have for a box that contained 2 hots, 2 neutrals, and 2 equipment grounding conductors, all of the 12 gauge persuasion in the 2017? Well, we know we're going to count our 2 hots, we know we're going to count our 2 neutrals, and all of the equipment grounds count as 1 total. We would have a total of 5 cubic inches. We do the math for 12 gauge conductors, and we end up with 11.25. Let's do one more quick practice for the 2017. We got 3 hots, 3 neutrals, and 3 equipment grounding conductors, all of the same size. We're going to take those 3 hots, the 3 neutrals, and then all of the equipment grounds count as 1 total based off the largest conductor that's in the box. That gives us 7. Now we bear our math out, end up with 15.75, and we select D. Let's go ahead and do one more for the 2017. We have the total cubic inch volume, and we have 3 12 hots, 3 12 neutrals, 3 14 hots, and 3 14 neutrals, and 6 equipment grounding conductors in the box. First, let's count our 12s, because that's what we're going to group all the equipment grounding conductors with, is the largest conductor in the box. We know we got 3 hots, we know we got 3 neutrals, and we're going to group all of those equipment grounding conductors, counting them as 1 with the largest, which happens to be 12. We take and bear that math out. Now let's deal with the 14s. We had 3 hots, 3 neutrals, don't have to deal with any grounds, they've already been dealt with. We take and bear that math out, total the two together, and we end up with 27.75 cubic inches. Now let's move on to the 2020 and the 2023. What is the total cubic inch volume you would have for a box that contained 7 equipment grounding conductors, all of the 12 gauge persuasion in the 2020 and the 2023? I left out all other conductors because you're going to use the same rules in that after you do this calculation, you group it with whatever the largest conductor is in the box, like you learned previously. What we're going to do is we're going to count the first 4 and count it as 1. And then a 1/4 inch increase for each one past 4. Sounds complicated. We're going to break it down very simply. We have 7 total, and we're going to minus 4 because those first 4 we counted as 1. So we have 3 left over, and we're going to take those 3 and multiply it by 1/4, and that gives us 0.75. So we have a total of 1.75 conductors based off whatever the largest conductor is in the box. In this case, there's only number 12s. So we would take that 1.75, multiply it by the cubic inch volume for a number 12 conductor, and we end up with 3.9375 cubic inches for our equipment grounds. What is the total cubic inch volume you would have for a box that contained 6 hot conductors, 6 neutral conductors, and 6 equipment grounded conductors, all of the 12 gauge persuasion in the 2020 and the 2023? First thing we're going to do, we know we take the 6 hots and the 6 neutrals, and we're going to set that to the side. Now we got to deal with the equipment grounding conductors. We're going to, for the first 4, it's going to count as 1. So we need to figure out how many we are past 4. We have 6 total minus that 4. That means we are 2 past 4. For each one of those, it's going to be a 1/4 inch increase. Take 2 multiplied by 0.25, that equals 0.50. Then we have our 1 original. Then we have 0.50 add-on, so that gives us 1.50 grounds. We need to take and add that back to the 12, so we take our 12 plus our 1.50, then we multiply that by the individual volume for a number 12, which is 2.25, and we end up with 30.375. Let's get to it. All right, y'all, that's it for this lesson. You can head over to electricalexamcoach.com to unlock the pro version and the unlimited testing center. We also offer our full program on USB drive and DVD, so you can watch it offline and without commercials virtually anywhere. It also includes the MP3 files of all the lessons, so if you just want to listen to them as you drive down the road or while you're on the job site, you can do that. You can check out all that in the link in the description below. Most importantly, I want you to know that I offer 100% free coaching in life and in business. Just email me at electricalcodecoach@gmail.com. I just want to see you guys win. Let's get to it.